Okay, so let me increase the volume so that everybody will be okay. Okay, so I was solving this in class, didn't finish it. I'm going to complete it now. Essentially we do the mean, right? And the mean we know is the sum of data divided by how many they are. So we're just going to do 79.3 plus 79 plus 92.4. We keep adding all the way to 92.1. Divide everything by, I think we have 7 items, 1, 2, 3, 4, 5, 6, 7. So divide everything by 7. Okay. So you have a calculator, right? Let me also try to do that here. Okay. I hope I didn't leave my class. Okay, it's right here. Okay, so let's try to see if we get the same value. 79.3 plus 79 plus 92.4 plus 79.9 plus 85.9 plus 90.8 plus 92.1 divided by 7. Okay, let me hope that we match the sum.
Divided by 7?
Yes.
85.6.
Okay, great. So we got the same thing. And since the answer said leave your answer in 2 decimal places, let's go ahead and do this to up to 3 decimal places. So we have 85.629. Yes, we're going to be using this as our mean. The next thing, of course, is to calculate the sample standard deviation, right? And we are doing all this. So the final question here says calculate the confidence interval, right? And we know the confidence interval is just your data, the mean minus margin of error and the mean plus margin of error, right? But now we know this will be a t, so if we expand this formula, we have mean minus t alpha over 2 sample standard deviation divided by square root of n as the lower margin, lower bound, and the upper bound will be the mean plus t alpha over 2 multiplied by sample size divided by square root of n. This will be upper one. So we know this is what we're looking for, right? But we are trying to get out a piece. We already know n. We're going to compute t alpha over 2, we're going to compute the mean, and we're going to compute the sample standard deviation. This is all we need. So we already got the mean now, 85.624. So let's go ahead and get the standard deviation. Okay. So I'm going to move this down, or rather actually just delete it. Okay, so it's better to do this on a table. I think it will be better. So if we have our table this way, let's say this is our data points, and this is data points minus the mean squared, okay? And it is the sum of everything we have. So the sample standard deviation, or rather, the sample variance will be the sum of everything we have on that column divided by n minus 1, right? And then, of course, when we get the sample standard deviation, sample variance, we take the square root to get the standard deviation. So let's get the variance first. Okay, so these values, I'm going to reproduce them. 79.3, so I have 79.3, and here we're going to do 79.3 minus the mean, which we got as 85,629 minus 85,629, then squared, right? Let's see if we can get that square at once. I think I will expand this. Make this out first. Okay. So I think let me work with just what. So this is 79.3 minus 85.629. What did you get?
I got 40.05.
Right, I got something. So here we have 40.056. And we'll keep the 3 digits since it says 1 to 2. Right? Then we do the next one. The next data point is 79, exactly. So you have 79. And so this will be 79 minus the mean, 85.629 again. So 79 minus the mean, raised to the power of 2. Let's see.
29, 44.
Okay, very good. So I've got the same here, 43.944. Okay, let's do the next one. The next data point is 92.4. So we have 92.4 minus the mean 85.629. So we have 92.4 minus the mean raised to the power of 2. What do you have?
45.859.
Yeah, 859.
Yeah, well, I mean, I guess
846.
8.
Okay.
I have 45.85994. So
Oh,
that would be
okay. I got a different thing here. Can we come? Let's try it again.
92.4 minus
Yes.
85.629. Oh, I have 68.
Yeah, 69. Yeah.
It's 45.846.
Okay, so that agrees now. So 45.846. So the next number data point is 79.9. So we have 79.9. And so we do 79.9 minus 85.629, and then we square. Seven 9.9 starts.
32.821.
Okay, I got it. Same, so 32.821. Okay. Then let's go ahead and do the next one is 85.9. 85.9, 85.9, and we are going to subtract the mean of 85.629. That's clear. Here is 85.9. Square that. It's actually a bit strange. Okay.
Right. 0.073.
Yes, I got some. So 0.073 is the answer here. The next value after 89, 85.9 is 90.8. So 90.8, 90.8 minus 85.629 squared. Minus 0.8 minus that squared.
That 26.739.
Okay, the same thing here. Thank you. 26.739. And then the very last data point is 92.1. So 92.1. 92.1 minus 85.629. So we have 92.1. Dot square. Yeah. What do you think?
41.873.
Okay, 41.873. So make it 874, right? Okay, yeah. Okay, so it's good. If I'm doing this, and I keep questioning and doubting myself, and I just repeat each one 2 or 3 times.
Absolutely.
All right, so let's go ahead and add everything and see what that sums up. 40 plus 0.056 plus 43.944 plus 45.846 plus 32.821 plus 0.073 plus 26.739 plus 41.874. Okay, hopefully we have the same.
What was the 26?
739.
Yeah. I think I had that one here. At 101.59.
I got something different. I got 200 or something.
Okay, I got
So,
26 of the last one.
uh-huh.
I did it backwards.
Okay,
The last one.
okay.
So that was the last one, plus 26.79.
Did you add 41.874?
Yeah,
Okay.
that was.
Okay. Was there already? Okay. Okay. So you added upward. Okay. Let me try this again and see if we can get something different. So 41.874 plus 26.739 plus 0.073 plus 32.821 plus 45.846 plus 43.944 plus 40.056. Okay, let's see if you get something.
That's different. I got 231.359. I mean, 0.353.
Okay, okay, that works. So that's exactly what I have. So we can go with that. So here we know that the sum of theta minus the mean squared, the sum of all that will give us 231.354, right? Rounded up. Okay. So I actually got 353, but let's go with that. So if we have this rounded off, we have this value. So that is our that's value. So we are looking for the standard deviation. That's our interest, but we can get the variance first, right? We know the variance is the sum of theta minus the mean squared divided by n minus 1. Now we have the numerator as 231.5, not 5. Yeah, 353. Where is the, okay, draw is over here. Good. So 321.353. Okay, so let's do it 353 then.
Well, I mean,
Okay, so let's say 354. Okay, divided by n minus 1, and n is 7, right? We have 7 data points. So 7 minus 1. So we're essentially dividing that by 6. So if we divide our result by 6, what do you have?
I have 38.559.
Okay, thank you. So 38.559. Now, so of course, we know that our standard sample standard deviation is the square root of the variance, right? So we just take the square root of that answer, 38.559. The square root of that will give us
6.20. Well,
yeah,
6.21.
21. Okay, so let's say 210, right? Yeah, okay. So this the 2 decimal places. So that is our standard deviation, right? Sample standard deviation. So now we've gotten, let's go back to the formula of interest. Our goal is to calculate confidence interval. It's like, I'll have to figure out a way to get to the next page. How do you do that with job moving like this and that? Okay, so no problem. Let me move it down. So then move this back up. I use the draw, select everything. Hopefully that works. Okay, so I'm gonna take this. I thought the mode should change. It's not changing. Okay, it's not. Okay, so let's see if I can move it to the next screen where it actually is. Okay, let's come closer a little bit. Okay. All right. So, yeah, this is disturbing. So, essentially, we did this, and I can keep it actually here. It should be over here. So we found out that the sample standard deviation is 6.10, right? And earlier we computed the mean, and we got that to be 85.629, right? Yeah. Okay, so let's write down the formula again for calculating confidence interval. Pick up the block. So we know that confidence interval is given us on the lower band, since we are doing a T, because we don't have the population standard deviation. So we have the mean minus whatever is the margin of error. And the upper band, we have the mean plus whatever is the margin of error. We know this is confidence interval. But because we're doing a T, we can plug in for margin of error. We know the margin of error is the critical value of T alpha over 2 times sample standard deviation divided by square root of n. So if we plug in for this in this formula, then our confidence interval, everything in a wider form, will be the mean minus critical margin of error, which is T alpha over 2 times sample size divided by square root of n. I mean, sample standard deviation divided by square root of n, right? At the lower band and the upper band, you have the mean plus T alpha over 2 times standard deviation, sample standard deviation divided by the square root of n. So this is our confidence interval. Okay, so now we almost have all the piece, right? We have the mean, right? We have the mean now, we have the standard deviation, we have n. So what is left right now is just T alpha over 2, right? So let's see how we compute that. Again, let me use red. So we do T alpha over 2, which is a critical T value. We can start by computing alpha first. Alpha is 100 minus confidence level. And the confidence level for this question is 95, right? Let me remove this so you can see that. Yeah, it's 95% confidence level. That's what we're actually finding. So let's go down. So our alpha will be 100 minus 95, which is 5%, right? But we're interested in alpha over 2, so alpha over 2 will be equal to 5 divided by 2, which is 2.5%, right? But again, we want to keep this as a decimal number. So if you change that by dividing by 100, you're going to get 0.05. Okay. This is just our alpha, but remember the core interest is the T critical value, which is T alpha over 2, right? And so to get that, we need the area, which we just got. We got that area to be 0.025. That is the area on the tail, right? And this will be one tail because we divided by 2. So we can say area on tail, one tail, 0.025. And then we need the degree of freedom, right? The degree of freedom is n minus 1, and here n is 7. So we should have 7 minus 1, which will give us 6. Okay. So when we go to the table, we are looking for a critical value that has the area of 0.025 on one tail and has a degree of freedom of 6. Okay. So I do have the T value here, so I'm going to pull it out very quickly. I think it should be somewhere here. Okay. All right. So this is our T value. We are looking for the area of, let's have it now. Yeah. We are looking for, let's move this. Okay. We're looking for an area. And I think it's better we use a different color. Let's use red. So on this T table, we are looking for an area of one tail that is equivalent to 0.025, and we are looking for degree of freedom of 6. Right. So if you go along one tail, we're going to get 0.025 over here. And then you're looking for degree of freedom 6. So if you trace where those two meet, you have 2.447, right? Let me make this bigger so we can see it better. Yeah, so wherever the area of 0.025 and degree of freedom of 6 met, the intersection is 2.447. So that is our T critical value. So I'm going to go back to the worksheet. So the T critical value here, T alpha over 2, is 2.447. So the mistake here is to stop, the common error is to just get your alpha and stop. People normally like stop here, but this is just alpha, right? Once you get alpha, you need to plug in to get the T critical value. You need to go to the table rather to get the T critical value. When you go to the table, you need degree of freedom. So combining that area and degree of freedom, you're going to get your T critical, which is 2.447. Okay, so now if we go back to this formula, we've got everything we need. We already have the mean, we already have the population standard, sample standard deviation, we already have the sample size, we know that already. So whatever that was remaining was just the T critical value, and we just got that. So now we have it, we'll complete our work. Okay, so let me go to the next page here. Okay, this one worked well. So to compute the confidence interval, and we're looking for 95% confidence interval, we know we need to find the lower bound, which is our mean minus margin of error. I want to repeat the formula again for clarity. And mean plus margin of error, this is what we're looking for. But we know that this is T because we don't have the population standard deviation. So we know our margin of error will be T alpha over 2 times sample standard deviation divided by square root of n. So if we expand that, then we're going to get our confidence interval to be the mean minus margin of error, which is T alpha over 2 times standard deviation divided by square root of n on the lower band. And then the upper band, we have the mean plus T alpha over 2 times sample standard deviation divided by square root of n on the upper band. So we're going to plug in because we have everything right now, right? So if we start plugging in, let's remove that. Doesn't confuse us. Okay. Let me see if I can get a darker green. All right. So if we start plugging in, and this is the mean, of course, then we're going to have the mean. We computed this earlier to be all the way to the top. We computed that to be 85.629. So we plug that in. So you have the mean. You have the mean to be 85.629 minus T critical. So maybe we'll just calculate the margin of error separately and then put it back, right? Because that will make it easier. So let me use right and do the margin of error separately. So let's remove this and be sequential. All right, so let's go ahead and say, okay, let me use right. Let's compute just this one, which is the margin of error, right? Okay, so already right now we've gotten T critical. So we could say E is equal to, we've gotten T critical to be 2.447. So we have 2.447 times the standard deviation. We know that to be, we got that to be 6.210, right? Mm-hmm. So come over here, plug that in. 6.210, and we're dividing that by square root of n, and we know n is 7. So let's see what is it. So we have 2.447. Okay, that should be 7. Multiplied by 6.210 divided by the square root of n, which is 7. What do you have?
5.717.
Oh,
718.
Oh, I got 743. Oh. Okay, let's try that again. So 2.447 times 6.210 divided by the square root of 7.
$5.743.
Okay, 5.743. So this is our E, the margin of error, right? Mm-hmm. Okay, so we just replace it in that formula. Let me go back to green again. It's the same kind of thing. So we know that our confidence interval will then be the mean, which is 85 point. What that is again? The mean is not over there, over here. The mean is 85.629, right? So we have the mean of 85.629 minus the margin of error we just got to be 5.743. That will give us the lower band. For the upper band, we have the same mean, 629 plus the margin of error, which we just got to be 5.743. So we have that 85.629 minus 5.743. Do you have an answer?
79.8855.
Okay, so let's make it 886. Yeah. All right, so that is the lower band, and then we go for the upper band, the same set of number, just add them this time.
.743.
Yeah, so that is the
oh, yeah,
the margin of error. Yeah. So we're going to add that to the mean to get the upper band.
91.3724.
3724. Okay, so let's say, yeah, 372. Okay. Yeah, so this is the confidence interval that we need for that question. It says the 2 decimal place. We just run to 2 decimal place, right? Which would be like 79.89 and 91.37. Okay, so this is really the longest kind of question we found here, right? It's the longest, like you just have your data, so you're calculating everything from scratch, right? You know, but again, the thing is to keep in view of the overall formula. Once you have that in view, and the simplest way I think to write it is just the mean minus margin of error. That gives you the lower band, right? And on the upper band, you have the mean plus the margin of error. So if you have this short one that is easy to remember, then you want to ask yourself, what is the margin of error? We know how to get the mean. So the margin of error, we know it could be a Z or a T, right? So if we know the population standard deviation, then it's going to be a Z. So that we have Z alpha over 2 times population standard deviation divided by square root of n. But if we don't know the population standard deviation, then the margin of error will be T alpha over 2 times sample standard deviation divided by square root of n, right? So whichever one it is, we can go ahead and solve that separately, right? And then we want to remember that in this formula, actually when I give this question, I will be breaking to say, hey, first calculate the mean. Second, I would say calculate the standard deviation. Third, say calculate the critical value. Right. Next, I would say CD, calculate the margin of error. And then finally, I would say calculate the confidence interval, right? Because I know you need to get all this to get to that point. So once you get your margin of error, which is made up of the critical value, right? Is a critical value, either Z critical value or T critical value. You know, if you compute that, and then you multiply by standard deviation divided by square root of n. That is your E. And so when you get that, you come back and plug it in. So remove it from the mean, you get the lower band. Add it to the mean, you get the upper band. Right? Okay, so that is really that. So, but when the formula is written this way, fully like, let's say, if I'm using Z alpha over 2 times standard deviation over n, you're actually estimating the population mean, and you know that that should be less than the mean plus Z alpha over 2 times population standard deviation as well. Yeah. So when it's written this way, it's kind of, you know, but if we think about it in simple form like this, and know the breakdown and all that, it's easy to put it together. Okay, I'm going to stop recording and hopefully this